Great, thank you, Katya. Yeah, so one of the most confusing, for some reason, confusing medical device categories to test and test properly has been electrosurgery unit testing. So we have provided test instruments for this kind of testing for many, many years, different products down the line. But today we want to talk a little bit more about that and talk about some really important things that you should remember about doing this kind of testing. So we'll cover why we test electrosurgery units, and they are, depending on the manufacturer, they're at least once per year, but many are twice per year when you look at the total risk score that we use on a risk-based determination of how often to test. And then there are global test standards that get translated and integrated into the brand and model specific test procedure that you'll find in the service manual for your ESU. We'll talk about some electrosurgery unit testing tips, and we look really forward to sharing with you in the Q&A at the end. So let's start with the basics of electrosurgery unit. What do they do? And so the electrosurgery unit produces a high frequency, radio frequency, if you will, electrical current that allows us to cut tissue and control bleeding through coagulation. The current flows through the patient from the generator back to the reference in the generator. So sometimes that'll be back to protective earth or ground. In other units, the more modern ones, it's back to the secondary of the power supply of the electrosurgery unit. And so the current will be delivered through cable electrodes that are activated through some sort of hand or foot switch. These days in United States and Western Europe, these are single patient use disposable hand pieces. The foot switches are certainly durable, reusable. But outside of that, in emerging market countries, we still find some reusable cables and electrodes for controlling cut or coag, and then how much energy is dialed into the ESU. Modes of operation include monopolar modes and bipolar modes. And the difference is, as you can see on the slide, how the current flows and to what extent it has actually flown through a larger portion of the patient's anatomy. So you can see in monopolar, we have an active electrode that's used for controlling cut and or coag, either through the handpiece or through the foot switch. And then the current has, in order for it to flow, it has to be able to get back to its source. So the way that's done is through a dispersive electrode pad, usually adhesive, but there are still some metal plates around in the world today, and those are certainly less safe. The gel pads are much more safe, but in any case, it's going to flow through that dispersive electrode back to the generator. In bipolar, although some of the electrosurgery unit manufacturers are recommending that you apply the patient return pad anyway, the actual current flow path is from the active electrode on one side of the handpiece to the other side of the handpiece, which is the return. And so we're using this for removing or resecting or cutting away tissue or to provide closer coagulation at the site of the surgery. And when we go to surgeries like endoscopic or laparoscopic surgeries, Band-Aid surgeries, you will find that bipolar modes are what are going to be used. And there's a specialization of the bipolar mode now also on at least 2 manufacturers that we know of, and that is called a vessel sealing mode, where there's a clamp. And this is particularly useful when it's time to cut away or cut through a blood vessel. And so within some diameter size limits, we want to cut and permanently close off the bitter end of that blood vessel so that it will not bleed and cause continued bleeding. And that's done with a heat effect caused by current flow and pressure on the applied on the vessel over a set period of time. And so there are specializations of that. Valley Lab calls theirs LigaSure, but they're not the only ones that have this modality. So that's a specialization of bipolar mode, just so you know. Now, it's important to also realize that there are particular and very specific waveform shapes when we're delivering ESU energy to the patient. And these are important to understand what good looks like here, so that when you're viewing this waveform while you're testing, that you can understand any differences that that would indicate that even if you have numeric values that are within testing limits, if you have distortion on these waveforms, that's not a good thing, and you need to keep that ESU away from clinical use until you find out why the distortion is there. So for cut mode, you can see on the left, it's a narrow, deep surgery obtained by a high frequency and low voltage, a wave shape. On a blended cut, the incision is a little bit wider, and it's a low frequency, high voltage in the pure cut mode. In coagulation, we see a energy delivery space and another energy delivery. And in this case, we achieve a high voltage and a low frequency, and the delivery is different, and typically the settings are lower compared to cut mode, whether we're talking about monopolar or bipolar delivery.
Well, Jerry, and that's a
Yes.
good point when you brought that up, buddy. You know, a good point to break is now, if you to look at these waveforms, you might need a few additional pieces of the test equipment you didn't always traditionally associate with doing ESU checks and services. You might want to think about having a oscilloscope with you to look at these waveforms.
Yep, and we're going to talk about that a little bit later in the presentation too. So, but you're very right, Justin, because viewing these along with the measurement, while you're making the measurement, if you can see both at the same time, it really allows you to decide quicker about a pass or a fail. Again, if there's distortion, I don't care what the measurement shows, numerically, it's a fail, and we want to remove that from clinical use, right?
Yes, sir.
So what can go wrong with ESUs? Well, burns still happen every year, everywhere in the world. And burns due to surgical fire are the most severe, although the least typical. Surgical burns not associated with surgical fire are also a very high incidence of occurrence worldwide for electrosurgery units, which is why it's important to make sure we test the contact quality monitor that looks at the dispersive pad to help us know when the dispersive pad is pulled away from the skin too much, and we increase, and therefore increase the risk of patient burns because of that. Burns due to inappropriate placement of that dispersive pad or patient return pad are also important. Burns to the test operator, that's you and me. because we improvise test connections and fail to understand the high frequency current risks. We're going to talk about that in a little bit more detail in a minute. The electrical microshock from either regular mains power and frequency or high frequency or RF electrical leakage current, and we're going to talk about that a little bit later in the deck too. We want to be careful about these things, make sure that not only we, but the clinicians, the surgeon and the circulating nurse are aware of these potential problems and risks and work hard even during the actual surgical procedure to protect the patient and reduce risk of injury. What we're going to be doing as biomeds is making sure that aside from those things that have to be managed during clinical use, that we're doing a good job of our testing, making sure that all of the functionality that should be there, that was built into the design of the electrosurgery unit, are working properly and accurately. So where do the requirements for testing come from? Well, certainly from the international standards. The IEC 61289-2-1994, high frequency surgical equipment, part 2 for maintenance, and the IEC 60601-2-2006, which are the particular requirements for safety of high frequency surgical equipment. Also, low frequency electrical safety international standards apply. So absolutely, if you are a medical device manufacturer, or sometimes, and certainly in design validation, but also in the factory for final assembly testing, and sometimes in the repair depot, service depot, after the repair is done, those are situations that are typically IEC 60601-1 electrical safety compliant requirements. And all of the rest of the electrical safety standard low frequency electrical safety testing would be governed by IEC 62353. But I would be remiss if I didn't also recognize that in some emerging market countries in the world, the IEC 62353 has not been adopted, and therefore the only international standard that there is the IEC 60601-1. You'll never be wrong if you're using and testing to the international standards. Just remember that the IEC 60601-1 is a design validation type test, and it includes tests that could shorten the useful life of the medical device. So typically that's why 62353 would be the more applicable to those of us that are in hospitals or are third-party service providers, independent service providers, and testing ESUs across a variety of different clinical facilities. All right, so here are some best practices. Always refer to the manufacturer's service manual test procedure, and whenever you can use that, that's the best one to use. The reason is because the manufacturer has adopted and integrated into their test procedure not only the tests that are important for international minimum performance and safety requirements, but also doing the testing in a way that properly tests their design, because the manufacturer of the ESU is the best source of information about testing that brand and model design. So you want to make sure you're following the service manual procedure. There are times, yeah, go ahead, Justin.
I'd like to jump in on there, buddy, because something that we're finding out as we're working with our customers in the field is to make sure not only they're referring to that service manual, but they have the most current version of the service manual. Some of these service manuals I've had, yeah, and they could have found some mistakes or adjusted the procedures in it. So every so often, it's a good idea to go back and make sure you have the latest version of your service manual and that you're following the most recent set of recommendations for it.
Absolutely. Now, I hearken back to my original experience in U.S. Navy with preventive maintenance procedures and keeping things current, in particular, obviously confidential material. We had to keep track of every notification of a change, a page change,
Yep.
a sentence change, all of those things. And that was part of the preventive maintenance best practice. So we had one or two people assigned to specifically make sure that all of our test procedures were completely up to date.
Oh
So
yeah.
Justin's making a really good point there. And if you don't have that work assignment, or you don't have that concept in your policy for medical device quality assurance, whether it's ESUs or anything else, our strong recommendation is you add it and you adopt it and you talk about it in your policy as what you say you're going to do, and then make sure you do it, because that'll keep you out of trouble when it comes on audit trail, but it'll also keep you out of trouble when it comes to litigation about negative incidents. So where a patient actually got a burn or something like that. So it's really important what Justin is saying about keeping current. Make sure you have the latest version, brand and model by brand and model of medical device, including and kind of especially ESUs.
Yeah, we've seen everything from steps changed to certain values changed. So yeah, it happens more frequently than some people are aware of.
Yeah. Now, this slide, we're talking about a application note that we have published about how to safely use Fluke Biomedical ESU QA-ES3 for high frequency ESUs to do the testing, to keep yourself safe. Now, don't get me wrong, both Justin and I have come from a long history of doing testing on these kinds of medical devices, and up until now, no one has provided a way to keep from us as biomeds having to improvise connections. And what do I mean by that? Well, we're going to test the output energy as controlled by the active electrode, whether that's a disposable handpiece that has a switch in it for cut and coag, or whether it's just the active electrode that we're going to control by the foot switch cut and coag pedals. Usually in the old days, what we would do is use an alligator clip to clip onto that, the blade of that active electrode. Yeah, not so safe. So we encourage you to actually go on our website and view this, maybe download it and make sure that you're talking about it within your biomed team for any and all that are going to do electrosurgery unit testing. We want you to be safe. So in QA-ES3, we have provided you with a very large number of different test leads, so you do not have to improvise ever
A lot
when
of
you're
them.
doing that testing. Yeah. And let me show you an example, and then Justin, I'd like for you to weigh in on this. So kind of here's what I'm talking about. The number one on the right is the way we used to have to always do it, and the way that many of you are testing today that we don't recommend. On the number two on the right is a non-improvised proper connection for ESU testing. And it's not the only way to hook that up. There are other ways, and we'll talk about those and how you know how to make those connections later. But this is an example of kind of like don't versus do. Okay.
Yeah, if you haven't been lit up by an ESU, I mean that was like one of those rites of passage when I first started being a technician. But there's so much more safe ways, and my face should probably be beside number one because that's how we did it for years and years and years. But he hits a very good point. And then so I can hear people in the background through telepathy here saying that, hey, you know what? Well, that's great, but I can't activate that ESU in picture two. Actually, we can. That's something we're going to show you here in a little bit, how you can actually activate that Force 2 using the QAS3. So there's really no need to use that pencil connection anymore. And please, whatever you do, For us really old school guys, used to stick the pencil in the front of the ESU analyzer. Don't do that. It gets really expensive in a big hurry. It'll arc it out. It causes that carbon buildup, and it's going to start taking more energy to pull the same readings. And it's going to throw everything off. So please don't use these improvised connections. So the question that comes up a lot and then is, hey, I have this specialty ESU that takes a special handpiece, and you don't have the cable for it. That might be the case, and with that, we're going to say go back to that service manual. There might be a special adapter that you have to buy to get into that service portion and perform this test, where it gives you a banana clip or a resistor or something to allow it to get into that service mode. So again, if you can't figure out and you have to go to that pencil tip, go back to that service manual and make sure they're not calling for a specialty adapter that they supply.
Yep, and we'd like to hear about any of those kinds of situations. I'm not saying we can always respond with a different test lead connector, but we need to hear about it. If you don't tell us, we kind of don't know. In order for us to deliver test instruments that really work and are easy to use and easy to hook up for you, we need to hear from you. So don't be afraid to let us know. You can contact us through tech support. That's a very standard way. You can share with us photographs. That's really good when you do that. But safety first, my friends. Let's stay safe. Let's make sure none of us are getting injured while we're trying to do minimum performance and safety testing.
Yeah, that hurts a lot of it.
So we need to complete all the necessary tests. So here's some examples of tests for different functionality that might be in the ESU. The CQM, which is contact quality monitor, that's also been called
ARM.
Oh man, REM, which is return electrode monitor. That's what Valley Lab calls there. Justin, you've run into a couple other acronyms for this. It means
ARM?
The same thing.
Yep, ARM, and now, geez, now that you said it, I'm gonna slip on the third one. But yeah, there it's same name, same thing, different names.
So that's a really important safety test. And unless the manufacturer has a different flow and sequence, that, in other words, that test comes in a different place. I know, Justin, you have a preference, and this is one of the tests that you would do number one, yeah?
Oh yeah. I always like to start off with my REM tests, and the reason is I want to make sure that works first, because I don't like being burnt twice. You know, when they're operating in ESU, they can always adjust a little bit to get the desired effect. But I always want to make sure that that REM or ARM or contact quality monitor is operating properly, because if it's not, then there's that potential to get burnt on a secondary where the pad's attached to you. So I don't like burns.
No,
So
none of us do.
That always works. So that's a big deal for me. I always check that ARM or REM, CQM first, and then move on through the rest of my PM, because it does.
Great.
It's been overlooked for a long time by a lot of shops.
Yeah.
Yep.
And then there's the power output tests for both monopolar and bipolar modes, both cut and coag. So those tests need to be done. Vessel sealing, if the ESU has a vessel sealing functionality, that needs to be tested. And in the case of Valley Lab, their vessel sealing mode, even though it's a specialization of bipolar, cannot be properly tested without being in the service mode. So if you want to know more about what that's like, we have videos about the full range of preventive maintenance and calibration tests for the Force Triad, and also now the FT10, so that you properly set this up and you're actually making the measurements that matter. And actually, QAES3 has a special vessel sealing mode for testing that is really handy and really useful for getting those tests done. And guess who the star of our FT10 testing videos is? My good friend, Justin.
He's a really good looking guy.
So you got questions? I mean, we're really trying to help you so you never are unable to do testing in the right way. Then we get to the electrical leakage test. So the high frequency or RF leakage current test is really an important test to do. It is part of the minimum performance and safety testing to keep the patient safe from microshock. Even at RF, which the human body can take more or higher current from and still be okay, you still need to do those tests and know how. And the low frequency leakage, which is our regular electrical safety tests, also needs to be done, and all of those have to pass. Now, another special function in some ESUs is an argon or inert gas envelope that it uses argon or some other inert gas to eliminate oxygen around the site of the surgery. And why is that? Well, because oxygen actually causes carbonization, okay? And so, and it also, that's charring is what you observe, and charred tissue is not clean, straight incision cuts, and they take longer to heal. So the reason for these argon and other inert gas envelopes is to get rid of the oxygen so we don't get carbon buildup charring, and the surgical wounds then heal faster, shortens patient length of stay, less cost of care, and higher profitability for your hospital. And guess what? That affects that you can get paid, or that you can get that next extra biomed tech that you need. So you're playing both to the patient's safety, risk reduction, as well as to reducing the cost of ownership by reducing cost of care. So it's really important that you know how to test those inert gas flow and pressure parameters. That's not a test that you do with QA-ES3 or any other ESU analyzer. You need something else, and we'll talk about that in a minute. And then power distribution tests, and these are important, especially when there's, number one, if there's a concern that as the tissue resistance increases, that the current flow and energy delivery to the tissue therefore decreases in an unexpected way and causes the surgeon or the circulating nurse to have to increase ESU output energy too much or too often. So there's this output energy guarantee functionality in some ESUs today. It's like impedance sensing. It's really sensing the impedance of the tissue by measuring the amount of current that has to be produced in order to achieve the power output setting on the ESU. And there's only one way to be able to do these tests. You can't do it with just a single test load inside the ESU. You need multiple test loads. And so we have actually built in for a long time a power distribution test where you can set up the maximum output energy setting on the ESU, and you can run it against a series of selected patient load impedances or resistances. So you can actually chart or plot the output energy and whether the output energy guarantee functionality of the ESU is working right. That is, for that maximum power setting, you get a flat response or the same output every time until there's a limit on that, and then it will fall off. If it does not, if the ESU does not have this output energy guarantee, then what will happen is very quickly, as the tissue resistance or the test load resistance increases, you'll begin to see that drop off in output energy. And so you want to look at the ESU service manual because it provides actual charts that show you what you should expect on this. And it's really handy to do that comparison of what you see compared to what is expected. And that can be built into your workflow when you do workflow automation to drive the test instruments and your test procedure. So how do we know about how to connect all of these different tests? How do we know how to do that? Well, on our website, there is an ESU testing connections quick guide for QA ES3. And we published this with photographs and descriptions to help make it easier for you, especially because a lot of these connections seem to be confusing to everybody. And you know what? I'm one of those that gets easily confused to make these connections right. I'm just being honest here.
Oh, I'm the same way.
Yeah.
We get, I'll freely admit, when I was out in field service, I always seemed that when we had to go do ESUs, it took you the first ESU or two, 2 or 3 times as long to remember how to do all those setups and which cable runs where and how. And I remember starting to take pictures and, share them in between all of us. And so it can be confusing. And honestly, with some of the earlier analyzers, it was very confusing, especially if your analyzer didn't have a ground source, if it's just like the old boxes.
Yeah.
So now with the QES3, though, a lot of this is made so much easier, really, really so much easier. And I got to tell you, some of the manufacturers have also done an amazing job depicting how the setups are in their manuals. I mean, the pictographs are so much easier to read. But the quick connect guide is another one. Just like Jerry mentioned, it really helps you lock it into it. The biggest thing to remember is monopolars, monopolars, monopolar, bipolars, bipolars, bipolar. Can there be exceptions? Yes, but for the most part, the connections are very similar between the ESU manufacturers.
So here's another tip. This needs to be shared with every single one of your buddies that's a biomed, field service engineer, or working for a hospital, doesn't matter. If they're testing ESUs, they need to know about the quick guide, the connections quick guide. They need to know about the videos that we provide, and you need to make sure that you've looked at them, and then share the wealth, man. Share the wealth. Make sure you're sharing that with your buddies so they know. And there's also training courses that we have, and we'll talk about those in a little bit, and they're free.
I'll go one step further, Jerry. I know that it's not so much in this webinar, but there's also workflow automation and workflow automation solutions that we offer that can really streamline all that data we're talking about. It's a great place to save it all, is in our OneQA workflow automation solution.
You bet. You bet. Okay, so we're ready for a poll question here. We'd like a little input from you all that are attending. And the question is, what test instrument do you use to test argon flow and pressure parameters? An electrosurgery unit analyzer, a gas flow analyzer, or you're not sure? And Edna, if you'll open the poll.
And the poll is open now.
I just feel like we need to have some kind of really cryptic music to be playing while we're waiting.
Justin, you can always sing if you would like.
It was close enough. It was close to me singing.
Now you're going to get the Jeopardy.
We kept our participants and didn't scare them off.
Now you're going to get the Jeopardy theme song stuck in my head the rest of the day. Oh my goodness. Thank you very much. How are we doing, Edna?
We're doing great. We're about 60% of attendees have voted.
Okay.
About 20 more seconds.
Come on, get your votes in.
Yeah.
We want to hear from you.
Well, I know what my answer was 10 years ago.
Hold your water there. Well, yeah.
And 5 seconds and the poll will close. And I'm closing the poll now.
Okay, and let's see what our results are.
So 16% indicated an electrosurgery analyzer, 65% indicated a gas flow analyzer, and 19% indicated that they're unsure.
That's actually kind of as expected.
Yep.
We're
I
very
agree.
specific. Go ahead, Justin.
I 100% agree with you, Jerry, because you know what? Like I was mentioned there, a few years ago, we didn't know how to test this. We didn't have, even though we had a flow analyzer, our flow analyzer wouldn't recognize argon because it's a heavier gas. It's an inert gas. So it doesn't just take any flow analyzer. You have to have a pretty specialized flow analyzer to do it. So we had problems with this. We were very unsure and trying to come up with the best solution.
Yep.
But now I know exactly what I'll do.
Well, so indeed, the answer that we're looking for here is a gas flow and pressure analyzer.
Yep.
Now, Justin, you're exactly right. The first time that we had any ability to provide a test instrument that could help us with this was the VT plus HF, but you had to customize in the gas using the gas calculator. You had to customize the user selection for gas type to argon or whatever other the inert gas was, and that took a little bit of doing. But now with the VT with the VT 650 and 900A, it's available to you. So no big problems, right?
Push of a button. Super easy to set up and do now.
Yep. But the electrosurgery unit analyzer is not, none of them, as far as I know right now, that are on the market are in the ESU analyzer itself, making it a possibility to do this functional verification for the inert gas flow and pressure. So you're going to need another test instrument besides the ESU analyzer. And so here's the set of test instruments that we believe, based on what we're hearing from you, what we see when we come out and visit you, and the expertise that we have, are required for comprehensive electrosurgery unit testing. And certainly you would have your electrical safety analyzer for doing the low frequency electrical safety. You would certainly have your QA-ES3 or a ESU analyzer. We recommend that you also have some form of oscilloscope, and you can connect that to the back of the QA-ES3, which has a oscilloscope output. Why? To view the wave shape of the output energy. And then for those special ESUs that have this inert gas or argon gas functionality, a good gas flow and pressure analyzer. So the neat thing about the VT 650 and VT 900A is very versatile. And so there are a host of different medical device, medical gas flow and pressure medical devices that can be tested using this particular test instrument. So it's not just for one thing, it's for like a lot of different medical devices. So
I'm not going to say that I've been in the field for too long, or a bit of a biomed by nature, but my wife and I, who's a surge tech, my wife and I sat down at the dinner table to see who could come up with a larger list of things you could test with the VT. She won by 2. Yep.
Wow.
Yeah.
I'm proud of her. Very good.
Oh yeah.
Good.
Yeah, that's the list we turn into marketing.
All right. So look, we know budgets are budgets, and so you can afford what you can afford, but it's important that you realize the set of test instruments that you need to do this comprehensive testing in order to get through any workflow from any manufacturer about ESUs. So just be sure that if you don't have it now, that you're making the budget entries and that you're acquiring these categories of test instruments to make sure you can actually do the full array of testing that needs to be done to reduce the risk of injury to the patient, ensure proper clinical effectiveness of the functionality of the ESU, and collect all of the information that you need. So we're going to talk a little bit about a special function of the QAES3 that can help you speed your testing. It's not required that you use the autosave functionality, but it can save you time in terms of running your tests in a way that allow you to save the measurements to internal memory, and then you can download that later if you need to. And I'm assuming at this point that we're still doing testing with the ESU analyzer all by itself, not interoperable with your CMMS or database. So, Justin, you've had some experience with this. You want to share?
I have. One of the features about the QAS3 is that we mentioned earlier that we can use the QAS3 to trigger your ESU, to actually turn it on. So replacing the function of that handpiece. You'll see in the top left corner there where it says switches. That's going to mimic the portion of the switches on your ESU. And when you do this, the QAS3 will actually save those results for you. And it can save all those results, and then when you're done, you can plug it into your PC and download those results out into an Excel spreadsheet. It really makes it nice, quick, and easy to do. So now instead of trying to transpose those numbers, you're pushing a button, it saves it, and you're retrieving it later. Especially for guys like me, I should have been a doctor by my penmanship. It's not the best. And when you're out in the floor and testing, you're an easy target. People like to distract you. They have 1,000 questions. And it's always easy for me to drop a digit or not take the reading. And this is just another way to help protect yourself to make sure you get it all in there. Not to mention, it automatically triggers the issue for you. So you're not having to use a handpiece or the foot switch, or, the thing comes down to your shop. It doesn't have the foot switch with it today. It's 2 miles back to the OR. Don't worry about it. Hook it up to that switch function, push the one test. There's your reading. There it's saved. Move on.
And I'm just going to remind you all about the videos, the application videos that'll show you how to make such connections, and also the quick connection guide. So
color coded.
Right. That's why we color code these, to help you. So use the tools and use the instruction, that the learning material that we provide you, to make sure that you're getting the most efficient way to do the testing, collect it with high accuracy, with good repeatability and reliability of your measurements. So now we didn't really walk you through an entire test procedure. We talked about all the things that need to be there, but there's one final step that you really need to remember to do. And I know if you're looking at this slide, I know you're thinking about a time that you got burned by this, right? You return the ESU generator back to the surgery, and then all of a sudden you get a call. It says, "What did you do to my ESU? It's not working."
You broke it.
Yeah. Wait, what did you do? You did not return the settings to their original values. So make sure you document what those are, what those original settings are when you start your test, and then make sure you return those settings to their original values before you take it back to the clinical unit.
Yeah, that also goes for make sure if they leave it plugged in or turned on and plugged into the cart shut off, make sure that you leave it that same way. I have driven many a mile because I accidentally shut something off.
Yeah, so if you're field service, you're feeling Justin's pain here. If you're biomed, I mean, where's the OR compared to where your shop is? How many steps? How many elevator rides? How many floors? All right. You think about that. All that is time that you could have been using for some other task or work assignment that you have to get done every month. Okay. So that means every day. So do yourself a favor, right? That's why we're sharing these as best practices.
Picture's worth 1,000 words in this case. Snap a picture of your cell phone before you start.
So we're just a reminder here about things that we're providing for you that are available right on the website for download. We have application notes and white papers about how to stay safe, about what is electrosurgery unit testing, a little primer. We have what to expect about particularly high frequency. We're talking about 1.5 megahertz and higher. There are some things you need to know about that really higher frequency. And year by year, ESU manufacturers are pushing the frequency higher and higher. And the reason for that is the higher the frequency, the lower the energy setting needs to be in order to produce the current flow that the surgeon needs to do the surgical procedure. And the safer it is, by the way, for the patient, as long as we're keeping track of making sure that that ESU is performing according to its manufacturer spec and the minimum performance and safety from the standards. And then, of course, the quick connection guide all the way at the right there. So don't forget about those. So there's an application page, and the URL is down at the bottom, flukebiomedical.com, application, electrosurgery. And that'll get you to where all of these things are easily and quickly available for you to download, either and keep them as PDFs or PowerPoints in the case of the quick guide, or you can print them out and have them handy along with your test procedure.
I will chime in for just a second, just to add to that, that on that page, the application page that Jerry was just talking about, you can also find videos that show you, the step-by-step test procedures and lots of advice and tips and tricks from us to help you perform your electrosurgery testing.
Really good. Thanks for that reminder, Katya, because again, we're trying to make it easy for you to always be successful in what you do. So thank you for sticking with us at least this far. I encourage you to stick around for the Q&A because it's always valuable. You may not have thought of a question that somebody else thinks of, and we're going to do our best to respond. So Katya or Edna, we're ready for the Q&A.
Very nice. Yeah, we had quite a few questions coming in through the Q&A pane. So one of the first ones was about the global standards that you were talking about, Jerry. So the question is, and it's half question, half comment, I guess a more of a clarification regarding IEC 62353. It is applied to the European Union, not USA, right? Because USA uses NFPA 99.
Well, USA uses NFPA 99 because that is a fire protection. NFPA is National Fire Protection Agency. And the NFPA 99 has been deemed an electrical code. And so it is enforced as an electrical code. That means the fire marshal is the one that audits you about that. So if you followed IEC 62353, you would not be wrong. You would have more than covered the requirements in NFPA 99, and the IEC 62353 certainly does and has been adopted as a United States electrical safety standard by NIST. And so, we can argue about this. I really don't want to argue. If you're following NFPA 99 and that's what you said you're going to do in your medical device quality assurance policy and program, fine. No argument. It's okay. It's okay. But don't think that the IEC 62353 therefore does not apply. It does. It's available to be used. And you'll never be wrong by following the international standard.
And it is used. There's a lot of our manufacturers and OEMs, OEM service who are doing that 62353 at the hospital level in the field. It's used quite often by them. And there's another technicality there, Jerry. If you're doing a repair and the manual calls out 62353 to the letter of the law, you should be doing that 62353 that the manual calls out.
Yes, if you don't do it,
repairs.
Right. If you don't, then you put at risk your hospital's ability to be reimbursed for patient care by the United States government for those patients for which that applies. So that's all your Medicare and Medicaid patients, and at least, okay? So yeah, you know, it's kind of important. So follow the manual, including, so here's the policy that if I were still managing biomed departments, and I have done so before, I would be saying, we will follow, for electrical safety, we will follow NFPA 99 unless the manufacturer's test procedure from the service manual says otherwise. Okay? Clear, cut, and then do what you said you're going to do. That covers your base.
Yep.
I hope I answered the question and clarified it for everybody.
Hopefully so. Okay, so the next question we have is about vessel sealing, and if you could elaborate on that.
Well, so we actually have linked to Valley Lab on our in our. Yep, we actually had in ESU testing, I think in our in one of our trainings, and also in our application note about that. I think we have included pictures of what vessel sealing looks like. So if I, as a surgeon, need to cut through and permanently close off a vessel in order to make it faster and ensure that the vessel is totally and permanently sealed, and I mean faster than having to cut it and then suture up the end of the vessel, because that's what I would have to do otherwise. The vessel sealing modalities, our functionality in ESU, allows me to just use a bipolar clamp, specific instrument, surgical instrument, to clamp that vessel, seal it, and cut it all in one step. All in one step. And yes, there are limits as to the diameter of the vessel that I can do that with. So if the vessel gets too big around, we can't do it. But otherwise it will. And the way it works is this pressure and heat over time causes the collagen in the vessel cells to turn into a glue. And that glue is permanent. And so over the appropriate time frame that's built in wonderfully into this new design functionality, it saves time and makes it safer for the surgery, saves time for the surgeon, makes the surgery safer and less likely to have bleeders that happen post-op. That's really how I can describe it. We don't have time to go back into and show you through everything. Valley Lab has a very nice description of vessel sealing on their that you can get to through their website, and we've linked out to that, so you can look at it a couple of different ways, get there in a couple of different ways.
Very nice. Thank you, Jerry. I'm kind of parsing through all the questions that we got. We got a lot. I'm just trying to pick some that we have not commented on before. We got a question to clarify the low frequency leakage current test and what does that refers to, whether it's part of the electrical safety test.
It is indeed the standard electrical safety test. Justin, have you run into confusion about that in your working more directly with biomeds in your territory?
Yeah, we sure have, and it's just pretty much a confusion of terms. So you're right. You have your standard, I shouldn't say standard, in your electrical safety test, and you're doing your ground wire resistance, and some of the manuals are calling it low frequency leakage, and it's the chassis leakage or patient current leakage. But again, it's really easy to test through.
Right, it's just your standard electrical safety tests. And again, if you're using NFPA 99, you should know how to do that. The other test that we must always do for ESUs is the high frequency or RF leakage current test, And again, refer to the connections guide in order, and the videos in order to see how to do that test. And the testing limits for the high frequency leakage are higher. That is, it allows more leakage current in the milliamp range compared to the standard low frequency electrical safety test, which is in the microamp limits range.
And I'd like to point out there's a setting on the QAS3 for doing a high frequency leakage test.
Yes,
It makes it
right.
real easy. It
So
changes where the loads are presented.
Right, the low frequency you do with your electrical safety analyzer, the high frequency you do with the ESU tester. I hope that helped.
All right, so with that, yeah, hope that was informative. And with that, unfortunately, we need to wrap today's webinar. We are at time. We do appreciate your attendance, your attention to our presentation, all of the questions that you have for us. Again, we got a lot of those, and if we did not get to your specific question, please send us an email. I think Dan already added Jerry's email to the chat window, so please take a look at that. If you have any questions you would like answered, shoot us an email. Otherwise, thank you all very much for attending today's webinar. Thank you, Jerry. Thank you, Justin, and we will see you at the next event.